lead today's discussion, please welcome moderator Donna Dodson.
Good afternoon, everyone, and thank you all for being here, particularly the NIST contingency. I appreciate that. Today we're here to talk about rocked to the core and looking at vulnerabilities. And I really have a wonderful panel here for the discussion. Paul Kocher, Maureen Allison, Phil Venables. We really have the A-team up on stage, and I'm looking forward to the conversation. But this is not just a conversation. This is really actually critical as we think about the world that we are in today and the world of the future and digital technologies, the directions that we're going. Over the past few years, we've had significant vulnerabilities in basic building blocks of core technologies. We've had Heartbleed and Spectre and Meltdown, Windows 10. As each of these have been discovered, the downstream ripples will be felt for years. We absolutely need to create a stronger, more secure environment. We need stronger products. We need to reduce our cyber exposure. But how do we do that? How do we get out of the game of whack-a-mole? What are some of the challenges in the development life cycle and things that we can do to address these significant failures? So with that, I'm going to start with the panel, and I'll start with you, Paul. If you can tell us, what do you see happening out there today?
Well, actually, I was going to start by saying I think it's hilarious that you put Windows 10 as the bug as opposed to the crypto API bug, but I probably wouldn't dig into that too much. I mean, if you look at all of those vulnerabilities you mentioned, there's kind of a common thread that connects all of them the way I see it, which is they all result from unsafe optimizations. So Heartbleed resulted from OpenSSL using their own sort of internally built memory allocator and a bunch of other things that made it really hard to analyze their code. Spectre and Meltdown are obviously results from use of speculative execution in processors, and the Windows 10 crypto API bug results from mismatches between the cached versions of certificates that have been validated and new certificates coming in. So at the heart of a lot of this, is the way I see it, is we have optimized away security over a very long period here. We've made choices to get products to market as fast as possible, at the lowest cost possible, with the least testing possible, with absolutely no sacrifices for performance. And when you start beginning with your set of constraints as saying, I can sacrifice none of these other things and security is the afterthought, it's very predictable that we're going to see things like these coming. So the very first step, as I see it, whether you're building a product or running a network or even managing the team that's responsible for it, is to embrace some inefficiency and say, we are not going to build the car that runs at 100% the max speed. We're not going to build the building with the absolute least possible amount of steel in it. We're not going to go build the airplane with one engine and one pilot and a giant rocket motor on the back that will get there half the time. We need something which looks more like a Volvo than a sports car. In the case of a processor, we need software with very different kinds of architectures than the ones that we have today. So, Maureen, you're kind of the boots on the ground person here on this panel. What do you see from these kinds of systemic issues? What does that mean for you and for your organization?
Well, in the past, where we would be a consumer of the product, we now have to fully understand how the products work. And we've always relied, and most of it in corporate America, is around the network. So if you make lousy IT and it's in my network, if I configure my network right, I can reduce my vulnerability because I don't allow the outside to come after it. And that worked fine for years. But as we move into 5G, it makes the concern of, will we have the right products in the 5G network that are now going to be communicating, and what will happen? And these aren't just, for, especially in my area, which is healthcare, we're not looking at an IoT sensor to tell you that, you know, your Ring device just went off. No, we're talking about healthcare devices. So now looking at the full supply chain and ensuring everything, what our bill of materials are going in, is going to have to be absolutely at the top of our issue. Where in the past, we were the victims of whatever new patch was going to come, but today we're going to have to up the game and actually require vendors to provide us more robust, resilient products.
And Phil, from your perspective, you've seen some of these systemic issues and the challenges over the past 20 years in addressing them. What's the big fuss today?
Well, I think you probably all appreciate one of the things is it's, you know, to Paul's point, not just these kind of optimizations that have been made that have impacted security, but against that, there's a more significant backdrop as well, in that we have a lot more, for want of a better phrase, homogeneity risk, that many of these products that have been optimized are more pervasive and consistent. So when these issues occur, we feel them more deeply than we used to do. I think similarly as well, when you look across the environment, we definitely only in a few segments of a few industries are we deliberately building in alternate systems and alternate resilience. There was a great paper a few years ago. Richard Danzig, the former Secretary of the Navy, led a group that wrote this paper called "Surviving on a Diet of Poisoned Fruit." And if you Google it, it's up there on the web. It's a really interesting kind of document. And essentially, its thesis is we have to deliberately plan for more innate resilience because we're always going to be fundamentally exposed to these types of risks. And then similarly, against that backdrop of homogeneity in many products, operating systems, and hardware, we also see the fact that we're running in environments that are more exposed to untrusted code that can then lead to the manifestation of some of these vulnerabilities. So I think that digitization of society, the inevitable network effect that creates homogeneity, and the fact that we are having the ability to run untrusted code in more locations just compounds this. And I think I would agree we have to keep fundamentally thinking of different ways to build more inherent resilience and security into these things. And I think, you know, the Spectre and Meltdown vulnerabilities and Google's paper last year about the universal read gadget was definitely, I think, puts paid to any approach that we're going to do anything other than hardware changes as opposed to perpetual software optimizations. The final thing I would say on the Windows crypt bug was kudos to our friends in the National Security Agency for making the very laudable decision to actually disclose and patch that rather than do anything else with it. That was something that I think we should give them some credit for in that.
Yeah. It undoes a little bit of the blame they get for NotPetya and WannaCry and so forth.
Yeah, it's all about the forward.
So as we're looking at these systems, and we receive the kinds of guidance from, say, from NSA or from other organizations looking at what we should do, we still have several unpatched systems, even from Spectre Meltdown. Why is that? What kinds of things do people need to know to make better decisions so that these risks that we understand that are systemic are not out there 3 and 5 years later?
Well, I think there's different kinds of issues with some of the different products. So like the Windows Crypto API bug was kind of the best case scenario. It was a security savvy company that had basically a bug in just a couple lines of code and a really well-oiled update mechanism to fix it. If you contrast with Spectre Variant 1, we actually don't even really know what a properly protected processor looks like. You can't go buy one because it's a problem with just a fundamental performance optimization that you need to use if you're a processor manufacturer and you want to be competitive. So at one extreme we have, you know, so long as you have Windows Update on, you're fine. At the other, we have one where we may never have a real fix to it, or the fixes will be this very messy, convoluted evolution. For the latter kind of problem, that sort of exposes something that we've been doing wrong as an industry, which is that we're not going back and fixing some of the foundational problems that have kind of accumulated. We still have buffer overflow problems popping up on a near daily basis. Even though we've understood this issue now for, 30, 40 years, we still have a bunch of these things that we haven't fixed, and we have to at some point go back and fix those, or we're just going to keep building these deeper and deeper technology stacks with every single layer being very, very likely to fail, as opposed to having relatively low failure probabilities. And as I look forward, a lot of the risk reduction efforts that I think we have to do revolve around fixing some of these really less exciting but really critical low-level technologies.
So we have two issues, right? We have the holistic approach that we need to think about for products and services that we're using both in hardware and software. And I want to get to that in a minute. But once something's been identified, what kinds of capabilities, what kinds of things, Maureen, are you looking for in order to be able to patch and move ahead? Why are these systems still unpatched after all this time?
So every time a patch comes out, we have to take a risk-based approach on what we're going to patch and where it sits in our environment. We actually could be in the middle of the development of a drug, and there's machinery in there that you can't patch. You cannot patch at that time, and that's where I talk about the network isolation. Because if it cannot talk to the internet or it's not on the network and it's in a PLC, I'm going to be far less worried about getting a patch to it versus the machines, the PCs that people use. Now, on anyone's network, 99.99% of your network likely can be patched within hours if necessary. It's going to be the long tail in manufacturing and where the technology is used, where that vulnerability is. In some of the devices that we've seen in healthcare, it depends exactly where it is, and sometimes the risk of patching is worse than patching. So you have to weigh that and take a risk-based approach. And that, it's very easy for just patch everything. But if you have a pacemaker that has the vulnerability and it's inside a human and you don't know what's going to happen to it, or you actually have to extract it out of the human, you're going to take a completely different view and have a conversation of, is it a health safety issue? Because safety is number one, and then it's going to be reputation and finance. And patient safety for us ends up being our premier thing that we are. And every time one of these come out, I have to go through the entire bill of materials of all our medical devices and look at where it is, how it's utilized, look at our factories across the world, and determine and decide where we're going to patch. We've seen some of the patches have come out that have not patching was much less worse than the patching. And then also even in instances, as we see now in China, with everybody working from home, and we'll see this in North Korea and Japan, or in Korea and Japan, and other countries also. Do the countries have the bandwidth to be able to patch? And what if you can't get it there? Is it better to have your people not getting a bad patch and being bricked? Or is it better to take the risk and having the ability to tell if you have a problem starting to develop?
Do you get the right kinds of information that you need to make that kind of risk decision?
Yes, for the most part. I mean, there are a few. I think one of the patches, whether it was WannaCry or Heartbleed, that literally the patch came out and it was more dangerous to apply it right away than not. Our process, and mainly because we have the healthcare manufacturing and we have to go through such a process, it became known that the patch was worse than the not patching, and so we were able to pull back and make a decision. But we take a risk-based approach on it and talk about it long and hard. And then where do we need to go? There'll be some things, there'll be components of PLCs out in our factories that are very old technology, and as long as it doesn't have a connection to the internet, let her run. Let her run, baby. Keep her going. Because that, if it doesn't have the vulnerability, I don't need to patch it.
Actually, building on it, it's interesting because I think there's not a lot of consideration given to that operational technology issue. There's that sentiment I hear a lot. We have a lot of companies that we're invested in the energy and health and industrial manufacturing sectors, and this whole push of like, why can't they just patch? Also, not only those operational risks of doing it, but also in many sectors, there's some pretty strict regulations about making sure that there's full system testing of software that's upgraded to guarantee the operational performance of those devices, and that includes in many cases patches. And so there's many situations where we're conspiring, industry regulations in some cases are conspiring against the ability of manufacturing companies to upgrade safety critical equipment in ways. And this kind of points to this broader thing that I think, again, you'll all appreciate because you're at a conference like this, is oftentimes companies, apart from those issues, are not deciding not to patch. They're making those decisions and trade-offs. And a lot of companies now, over many years now, I think a lot of you will have done, is invested quite heavily in their software update pipelines and their change management processes so that they're getting better at updating and releasing software for all reasons. And once you've done that, you can take more risk with introducing patches because you can then test it quicker and roll it back if there's a problem. And so engineering our environments to be more to have the more inherent ability to patch and update is probably a more important thing over time than just worrying about individual patches. So I think figuring out a way to get patches into the environment as opposed to so you can put more patches in the environment and more software updates is the critical problem. Right.
And as you look at the long tail of devices, the patching approach also doesn't work very well. I mean, for the really big companies, the Microsofts, the Apples, and they can get a high-quality, well-tested patch out pretty quickly. But as you look at what the patch production process looks like for a small company, you have a whole bunch of things that are very dangerous. You have developer laptops or workstations with poor hygiene. You may have distribution channels that are insecured. So the question of what are your risks that you're incurring through just getting that patch are also non-trivial, and it's not just functional problems, it's security issues as well.
So we've talked to, kind of at the end of the life cycle here with vulnerabilities, and the answer is a risk-based approach to patching. But certainly, there are many things that we should be doing kind of upstream from that, right? When we're looking at products and services, when we're working with our suppliers, when we're buying products, how can we be better consumers? What are some things that users and consumers can do to understand and minimize, and then, if needed, mitigate the risks from vulnerabilities? How do we get ahead of this game?
So part of it is understanding the bill of materials that's going in, and do you need the component? The one that I don't know why every product from Microsoft has to have IE in it, even if I don't want it to go on the internet. But I find all the time that manufacturers think that's just a great feature to have. And so we started going through with our operational technology organization and looking at, are there pieces we don't need? And really looking at what are the vulnerable pieces of the software and hardware we're now getting, and why are they there? We're also looking at, for us, as we build products, is what are those pieces we need and when do we need them? And you have to remember, some devices that you build and create actually go into others' networks. And then it's how to look at how are they secure and how you will operationally deliver patches when necessary. So there's a lot of layers to it, but probably the easiest one would be build it secure up front.
How do you do that? Phil, how do you do that?
Well, it's interesting because I think more broadly, I mean, where you're going with this was, I think a lot of organizations are underutilizing architectural choices to mitigate vulnerabilities. So we're always going to have, like, we all know, software's always going to have bugs. Some of those bugs are going to be vulnerabilities. Some of those vulnerabilities are going to be on an exploit path. And therefore, you just got to live with that, and you got to update the environment. But we should be less susceptible to one software flaw being somehow creating a high risk in our operational environments or supply chains or our customer-facing business or anywhere else. And I think there's a lot of things we can do to deploy, to place different components of different systems in ways that it's a bit like what they call in risk, they call it the Swiss cheese model, which sounds like a bad thing, but essentially you line up all the holes of something. You should never be able to get one thing straight through all the holes in the system. It should line up in a way that there is at least one line of defense because of architectural choices. And I think that's an under-researched, understudied problem, and I know a lot of organizations are having a lot of success with those architectural choices that give them the flexibility to change controls and not be susceptible to any one failure. But I think it's easy to say everybody should just produce more secure software, and a lot of organizations are spending a lot of time on that. It's generally hard, but if they do that in conjunction with thinking about architectural choices, one of the things is when you look at some of the larger data breaches that have occurred over the past decade, sometimes you look at that and the companies that were vulnerable to that, they essentially had a compromise because of one control problem, like one flaw, one unpatched system, and you think, how can that one thing result in that huge event as opposed to there being some kind of segmentation, separation, data minimization, other choices they've made to mitigate the impact of the one event? And that whole kind of reducing the blast radius of events, I think, is something we need to do more of from the hardware up through the overall end-to-end systems architecture. I think is going to be something that we'll see a lot more companies doing.
You know, I look to how other industries solve problems often when I come up with one, and looking at how aviation, for example, gets pretty good safety overall, or how structural engineers work, and all of the other industries that try to get something to be reliable and safe rely on redundancy. And what you're talking about with getting multiple layers there is fundamentally an approach based on redundancy. But if you look in contrast at your typical piece of software or piece of hardware, there are hundreds of millions of lines of code, billions of transistors, every single one of which is a single point of failure. So we have not figured out correctly how to use redundancy. There's some sort of preconditions. Certainly you need memory safety, because if you have unsafe programming languages where any line of code can destroy the security of anything in the entire process, you're not going to be able to get any sort of redundancy. But even after you have memory safe languages, it's just not used. And if you had redundant verification of certificates, for example, that would have addressed both the Microsoft Crypto API issue as well as like Apple's go-to-fail and a number of other bugs. And so when you have something that's really critical, like verifying a cert that came in from the wilds of the internet, having two pieces of software check that has very little cost compared to the cost of having extra structural supports in this building. Yet we're not doing it, and we need to start doing things like that.
So you talked earlier about things like Spectre and Meltdown, and perhaps we really need to rethink our security models. So redundancy is one of them. But what else do we need to do?
Well, one of the themes of this conference is the human problem, and all of us people who are older, and I'm starting to reach that age here, grew up in a world where security didn't really matter. Compared to the economic benefits of making things faster and cheaper, those were where you made your money. That's where you were successful. That was where you had the big wins. And security problems were an interesting academic question, or maybe they'd show up in the New York Times as a thing people were complaining about, but it wasn't really the big issue. And all of the thought patterns that were developed during this period where security was insignificant have stuck around. So, I met with somebody working on one of the major browsers and was talking about a security mechanism that would add around a millisecond per page load, which was utterly unacceptable. So, that might cost you a whole second per 1,000 page loads you do over your day. Now, I actually suspect there are people in this audience who'd be very happy if their employees had another millisecond on each page load and had significantly better security as a result. But there's this mantra that page load times matter more than security does. And so we have to change those beliefs that were formed in the prior world where performance gains were huge and security was costing millions, not hundreds of billions to trillions of dollars, in order to be able to make the investments needed to go and actually address a lot of these problems.
Yeah, but it's interesting, and that's a great example because it also points to the lack of an overall mature risk discipline to think about those decisions. So that browser example is a perfect example, is because nobody knows how that 1 millisecond adds up over a potential set of other activities in and around the browser because of how people may have built software on it, everybody's only choice is to default to the not give anything up. But if there was a broader environment to look at what the consequences of that would be, the developers themselves may realize it's not actually consequential and therefore to trade for safety.
And there's actually a test that I'm trying to get somebody to do, which would be to offer 2 versions of the software, a faster version and a safer version. And just see what the population does. I mean, I don't know if I can ask for hands in the room. How many of you would download the safer version of a browser? How many would go for the faster version?
Not fair, you're at a security conference.
Shh. At least it's data support my perspective.
I like your statistics, though. But you know, there is another side of this. Many companies, when we looked at it, and if you look back 10 or 15 years, it was how to make IT be cheaper. So part of that was to consolidate, make flat networks, put less friction into the system. And companies spent a lot of time and money to save money, right? And they ultimately did it. But it wasn't until, and we had all of the CISOs I know, detect and protect, and there we were out there putting more technology in to look to detect and protect and defend our organization. But somehow, it wasn't until NotPetya when I know myself and my other peers that I've talked to went, holy crap, it's about cyber resiliency. Do we have cyber resiliency? And there's a lot of supply chains out there and a lot of companies, and the OT element of what was being done there was not seen as, in some companies, not even related to IT. They were separate. Well, what I've seen so far in doing some inventories is they have 90% more internet-connected equipment than in the IT side. And so when you start looking at that and the numbers, where's the risk? And because it wasn't under the purview, and some of it actually gets back to organizational structure, where the CISO reports to, and the like, but looking at company resilience overall, and certainly I'm sure the Sony breach and Home Depot breach and on and on and on, but not to NotPetya did everybody have a wake-up call and say, oh wow, how I operate can create the vulnerability. And once that occurred and companies started looking at their supply chains, it was like a rush to supply chain. I was at the Executive Security Action Forum yesterday with 150 CISOs, and the amount of people who were doing OT security exponentially has increased in the last 2 years. Exponentially. People were literally looking at the stats from a few years ago, were barely scratching the surface. Today, almost every CISO has it on their plate to look at. And I think this is some of that area of actually understanding that redundancy. What are you going to need to do? And certainly companies cannot afford to have 100% perfect security in 100% of locations with full redundancy. But what you need to do now is back into some of the business continuity planning, your business impact analysis. What is important to your company? What are your crown jewels? And if something had to go down, what are you willing to take a risk on? And you know, I hear a lot as, well, nothing. It's all going to be up. Well, if it is, then start taking out the checkbook, because that will cost a lot. And I think between I'm not going to be able to patch everything in 2 days. I'm not going to be able to have full redundancy on everything in my entire corporation. It starts to be more of a risk approach that people have to understand in their organizations.
Another sort of technical or organizational structure issue that I've come into in a number of different directions is that you often will find companies that have a lot of complex, often technical work going on, but with no security knowledge within that particular function. And this was certainly part of why Spectre didn't get caught earlier, is that people working on things like branch predictors weren't asking themselves what are the security implications of this. They were only asking questions about the performance implications of what they were doing. And as soon as somebody comes along from the outside or from somewhere and says, hey, let's think about the security implications of what we're doing in these different components, suddenly a whole bunch of questions get asked and things get discovered that were being neglected before. And so making sure that there's enough security knowledge in the various groups in the organization, so if something is going really wrong, that the information gets fed back up, or if the assumptions about what security properties a given component or job function needs to provide have changed, that there's some communication about that.
But you know, it's much easier to be a security engineer. I love being a security engineer and doing that work, and I typically do it with other engineers and IT people, and they listen, and we have good conversations. It's harder to be a security consultant to the business, and especially in the digital area where you have a lot of people looking at big data and AI and the next best thing that they're creating, and you may have to cause a little bit of friction to have the conversation. And hey, as an engineer, am I equipped to have that business discussion around making sure things are secure and what that would look like to my corporation? So that is a big part of it. Hey, you know, again, the ESAF, there was a question. Over 50% of the CISOs spend 80% of the time talking to their team and 20% of the time talking to their companies. The reality is a CISO needs to spend 80% of the time talking to the business and 20% to their team. Because our job is consulting, and hey, the engineering part is real fun. I love that. But the most important job we do is consulting with our businesses so that we can do the right product.
Well, I think as well, to both your points, it's important to equip teams with the ability to not just think about security risk or not just think about what their productivity goal is for the particular product they're designing, but actually to think about all the spectrum of risks. So there's software reliability risk, capacity risk, resiliency risk, security. In different industries, there's different risks of whether it's finance, health, energy, there's all sorts of different risks. And figuring out what the right engineering, production, and quality process is to make sure that all those risks have been considered. Because there's been plenty of examples in many companies where companies have made the right decision on security, and they've pushed security down, and it's created an unintended brittleness that spiked a resiliency risk that in hindsight, because of some resiliency issue, they wish they'd have made a slightly different trade-off and maybe accepted some insecurity in the name of resiliency, because for that particular product, the most important thing was a certain resiliency approach. And so thinking about how organizations manage their, for want of a better phrase, their risk appetite, what's the risk envelope for a set of risks for a particular product in a particular business context, I think again there's some organizations are quite mature on that in certain industries, but generally speaking, how you manage that interplay between risks is quite underutilized in many organizations.
So Phil, when you were a little bit more boots on the ground than you are today, how did you manage resiliency risk, enterprise risk, customer risk, and cybersecurity risk?
Yes, so I was, a bit of background, I was CISO at Goldman Sachs for 17 years, and then from that I moved to be Chief Risk Officer for all of our enterprise risks, and now I do things for our private equity and our corporate clients, as well as sitting on the board of our bank. So I've kind of been across each of the layers of this. I get the privilege of asking difficult questions to my former team that I used to have difficulty answering when I was on the other side of that table. But generally speaking, what we did in the technology organization, we created an integrated technology risk team. So we had our CISO now, a guy some of you may know, Andy Osmond, we hired from Homeland Security a few years ago. So he's our CISO and head of tech risk. And so we think about managing the security risk, but in the technology risk portfolio, we think about change risk, production access risk, software reliability, capacity, resiliency. And so bringing it all together into one risk framework has enabled us to start thinking about those trade-off decisions. And then separate from that, in our independent risk management function, which reports directly up to our board, we have a whole set of teams that not only manage our financial risks, but manage all of our enterprise operational risks that act as a check and balance on those individual engineering decisions. And that's where we apply the business risk context to set a board-approved risk appetite for how those decisions are made. And then ultimately at a board level, both our holding company and our bank boards oversee whether that whole framework is being executed effectively. So it's about bringing all of the different risk disciplines together. And moreover than that, in our scenario planning approaches and kind of incident learning exercises and drills and exercises, how we constantly prepare for these things, it's not picking one particular scenario like a data breach. It's usually picking a combination of scenarios that you really wouldn't like to happen at the same time, and then say, those are going to happen at the same time, let's see how we do, and that kind of tests the edges of things. So bringing all the risk functions together for us has been, and I think most large financial institutions do this, whether they choose to or whether regulators ask them to do it is a fairly useful practice. But I think the challenges are there's still a lot of work going on to the things we talked about before in terms of studying what's the modeling techniques, whether it's threat modeling or risk quantification or other types of modeling that can yield useful insight into those teams to make those decisions, as opposed to it being solely based on experience and judgment. There's a lot of value for experience and judgment, but it's also nice to augment that with actual models that deliver useful predictive results.
So we've talked, we kind of started out with vulnerability management. Now we've worked our way into resiliency and strong risk management practices. But given that we have, where I live, it's 1 foot inside the Beltway, 1 foot outside the Beltway, we hear a lot about certifications and certification programs to deal with vulnerabilities. Will they help? Will they hurt? Well, what would the effect if? What are your thoughts on certification programs?
So I have been around for SOX, HIPAA, and PCI. And from the healthcare perspective, HIPAA and protected health information, the HIPAA law, the privacy law first, and then the security rule were absolutely imperative to helping to change the paradigm of what we could do. It was now required. Now, I do believe that the HIPAA rule is too narrow. It's on protected health information versus all health information. And the ability to have a rule that is more broadly applied, I believe will build a better game. I mean, PCI came out, it had some holes in it when it first came out, but thank you, banks. Thank you, right? Because it required me to do that if I was going to take credit cards, and I took a lot of them. Yep. So it helped my program. And I think for the larger corporations, the larger entities, it sometimes feels like what are you doing? My cheese is good, don't bother cutting it around the edges. But I think for the smaller companies, it raises the bar. And so I'm pretty much, an advocate, having gone, 2005 with SOX and putting the IT controls in at least 2 different companies, managing them still today at Johnson & Johnson, as well as watching HIPAA and PCI evolve, that having those standards around data, having 50 different privacy laws in 50 different states, that is not helpful. That really is not helpful. And if we could get a standard around people data or healthcare data, from my perspective, I'm all in.
So I'm going to give maybe a counterpoint to that.
Okay.
My experience with certifications often is around the things where you're trying to come up with some kind of a, gold star that somebody would put in the product to say that it's secure. And the economics of the systems end up generally being completely backwards. The vendor pays for the certification, which means that they're incentivized to pick the weakest certification process that will get them the gold star, which will help them sell products. So this is really a sales exercise. And in many cases, the sort of overall process, no code gets harmed during the certification. So nothing changes. It's entirely a paperwork exercise that gets done at the end of the engineering process, at which point the product often becomes very brittle because you can't update it. The testing lab perspective is in some cases even worse. There was an anti-piracy standard that came out, and somebody really wanted my team to do evaluations there, and I did one, it was fine. Then the next 2 or 3 requests that came in, the vendors were saying, am I worse than the worst product in the market, and can you tell me that I'm not so that I can go sell this thing? And it was very clear that this was a race to the bottom. And other companies that were doing evaluations were all trying to make things as cheap as possible, which meant you couldn't actually pay good people to do the reviews because you were trying to be absolutely as cheap as possible. And so all the incentives basically drive you to something where it becomes a marketing exercise that consumes paper but doesn't make the products better. So now, there's a certain idea that maybe if you force somebody to go through having a money bonfire or doing some sort of silly work, you kind of weed out the people who don't really care at all about security. And there's some argument to that. But in most cases, from what I've seen, at least working from the technical side, that the resources spent sort of doing certification at the end of a product's design cycle would have been much better spent if they'd been invested in doing improvements in the engineering process. And at the end of a product's sort of life development process, even a very simple question of the vendor like, what is the probability that you have a security bug and why? Write me a 1-page explanation of what you've done and why. Often can give a lot more insight than a gold star or the lack of a gold star from a third-party testing lab that was handed megabytes of source code and had 2 weeks to look through it. So that's the sort of cynical counterpoint, perhaps.
Yeah, and I'll counterpoint back your counterpoint.
Excellent.
Because having worked with the FDA on the cybersecurity protocols for medical devices, I think it's absolutely the way to go. Because of the ability, then you're bringing evidence of what you have talked about. There's testing, there's pen testing. You have to have a vulnerability management program. You have to have an ability to update. And so it's a lot of operational items. I agree with a UL type testing on an IoT device. That may be one thing. But when you're talking about something that's in human health care, having it absolutely certified and having it reviewed is imperative to health safety in the United States.
And actually, I think we kind of agreed there because
Okay.
you talked about resources
Yes.
being spent in the development process and having.
You notice we both wore gray suits too.
So Phil?
But it's interesting. So I think I'll kind of generalize this up a little bit. The problem, so certifications, regulation, everything else, I think are necessary but not sufficient, and I think they do run the risk of getting gamed. And if you only rely on that, then that's probably a path to danger because you've got to do other things. I would say, though, with metrics, it's interesting. So we've spent a number of years kind of quantifying certain things with metrics. And again, this is a lesson many organizations have learned. Anytime you have a metric, there's going to be an unintended consequence of that metric. And so it's important to always have a second metric for every metric that looks for the unintended consequence. So there's plenty of stories, not necessarily in security, but in other walks of life, where there was a thing in many decades ago in India, there was rewards by the government for killing and handing in poisonous snakes. So what do you think happened? Everybody started breeding snakes to kill them and hand them in to make money. So the net result, there was more snakes. There's loads of other examples of that. So every metric you have, you've got to have another metric that looks for the unintended consequences of the primary metric, because there always is. Yeah.
So can we do that in this space? Can we have meaningful programs to look at
I think we can.
vulnerabilities?
I think some of the challenges we have that other risk disciplines in other segments, whether it's engineering or safety or other things, tend not to have is that I think in many quarters in security, we're striving for the perfect measures or the perfect models as opposed to the models that are just useful enough. And I like the notion, we do something similar to what Paul was saying, which is just asking people to rationalize their choices, whether or not it yields a useful and consistent mathematical model, but using quantitative analysis to analyze their decisions yields a thinking process and a process discipline that they wouldn't have done if you hadn't otherwise asked for that. I would also say is just never underestimate the basic ability of basic counting metrics and basic metrics to say how many of these things have we done in these places and does that conform to the right control envelope that we expect. But you end up using a variety of things. We've done a lot with scenario analysis and Monte Carlo simulations, which, for certain cases, there's not enough actuarial quality data or not enough consistency of the models to drive a useful outcome. But in many cases, there absolutely is. We've done a bunch of stuff on Bayesian network modeling. Again, for some domains, it's not a useful tool and there's not sufficient data to drive the models. In other domains, it absolutely is. And so we've got less hung up on modeling is bad unless we can use that model for all things, and really focused in on what's the best model, best quantification technique for a particular case in point, and then constantly evolving that, because sometimes the situation shears away from the modeling and you've got to reset the modeling. So I think we've got a lot more comfortable with not necessarily always being right in every case, that there's a lot more ongoing experimentation. And that's exactly the same that every other quantitative risk discipline in other fields do. There's no kind of, there's no absolute kind of universal laws of how to do this in every industry. It's just different.
But when I've looked at models like that, the one thing that always seems to jump out is that the biggest improvements that you get come through reducing complexity in interactions.
Yeah.
And in some ways, I kind of think of complexity as the toxic waste of technological development. And if you can, whether you're stripping out unnecessary copies of IE or reducing the number of dependencies that you have in a piece of code, all of these shrink your problem down and reduce the complexity of what you're dealing with, and let you focus more resources on what's left. And everything good happens from stripping that stuff away.
Yeah, and in particular, the dependency isolation piece. So we've yielded so much benefits by isolating dependencies between systems, so individual system components can be upgraded without worrying about the knock-on effects. Has yielded a lot more agility. That complexity reduction, but really dependency isolation has been key. Right.
It's interesting reading that, like Boeing discovering that they have debris in some fraction of the fuel tanks that they manufactured recently. And if you kind of think of the software equivalent of that as how much debris or unnecessary software and code do you have sitting around in your critical systems, I bet there's more than just one little piece in some fraction of your fuel tanks. I bet it's a much, much bigger problem for all of us here.
So we've heard from each of you some notions about what we can do to get a handle on vulnerabilities, whether it's redundancy or taking a look across your system and seeing where you have dependencies that lead you to very bad outcomes, et cetera, et cetera. But for the folks who are sitting in the audience who have to deal with these vulnerabilities, who have concerns about Spectre Meltdown, where we said maybe not a lot we can do there. With the crypto APIs, we all know cryptography is hard. What are in the couple minutes that we have left, what's some really concrete advice that the folks in this room can walk away with from you all on dealing with vulnerabilities today and in the future?
So probably the most important thing is know your bill of materials. What is making up your systems? And literally that means data centers, as well as what do you use for compute, configuration, how things are set up are extremely important. And this is one of those, it sounds so easy, but when you rinse and repeat over 1 million lines of code or 1 million pieces of equipment out there, becomes hard. Very hard, especially when with the human element you have people who can configure things. And so that becomes back to this, the life cycle of the product. Do you know what a product is connected to? Do you know what it's made of? Do you know what it's connected to? Do you recertify it? in certain instances, if it's in critical areas of your network or in your compute area or product? And are you able to manage any risk that comes out with it, and how are you going to respond to it from a resiliency?
I think that the other one, just very quickly, would be to, and we kind of touched on this in the discussion, is we've got to reduce the dependency on the central security teams for the security of the organization, and just basically for every software development or product team in your organization, making sure they've got the training, the tooling, and the oversight to make sure that people are consciously taking the right risk decisions. And then the security team is about overseeing how all that process works, not validating the output of a team that is not able or equipped to produce secure software.
And then from a technical perspective, I would add to that also trying to build components that are as isolated as possible, where you understand all of the interactions, and ideally even have monitoring and analysis capabilities on each of those interactions, know what state that each component maintains, know what its characteristics are supposed to be. So really trying to take what is often this sort of evolved giant ball of string and trying to divide it into a set of small individual components that talk to each other in an understood way. And that may mean turning off things like hyper-threading or APIs that are enormously complicated, where you have a lot of interaction between components that are hard to characterize, and recognizing that there will be some cost to this. So you will not have as fast a system when you're done. You may have a system that has worse performance, higher cost to operate, but at the end of the day, it'll be more resilient because you'll be able to focus resources on just the components that are failing rather than the entire system failing in some complicated and unanalyzable way.
So people, process, technology, looking at it together, looking at risk management and resiliency, and maybe stepping back a little bit from perfection in cybersecurity. Hopefully this will be good takeaways for folks in the audience. Thank you all for being here. Thank you all to the panelists very much for your time.
Thank you, Donna.
Thank you, Donna.